Welcome! What's up, guys? Who this be, man? I don't know.
It's not Miss Everly. That was not my voice. Okay. If you thought so, well, you're wrong. It wasn't. All right. So today you are gonna be learning about some more triangle stuff. And before I say the name of the section, which maybe you already looked up, maybe you read it last night before you went to bed. I'm sure you did. You're going to run into situations like this, okay? Where you have a right triangle, you have one side given, and you'll need to find the other leg and the hypotenuse length. So what? Can you do that? You can, but not by using the Pythagorean theorem. You can because these triangles are going to be special right triangles. So that's the name of this section. That's the concept we're looking at. Okay, and we're going to look at two types of special right triangles. So get ready. Here we go. First with me. The first type. Well, this triangle originally started out as a square. Okay, so we have a square. Let's say the length of each side of this square is x. After we go through this, you might just say,
that was easy.
but maybe not. So with this square, if we cut it along its diagonal, whoa, we go from a square to, that part went away. Hold on. Boom. To a right triangle with both legs having a length of x. And then these angles are also going to be the same. That's what's special about it. Because the square got cut. The square used to be 90 degrees. Now it's 45, half that. Meaning this one's also 45. So this is a special type of right triangle known as the 45, 45, 90 right triangle. And in this case, we have our side lengths. We're going to say our x, our legs, and then the hypotenuse. I'm going to go ahead and have you figure it out by the Pythagorean theorem. And then we'll just have it in our notes and you can reference it and you won't have to use the Pythagorean theorem every time. But if we go ahead and make use of it, I would have my leg x squared plus the other leg squared equals the hypotenuse squared. So we're trying to find this length. So now if I add the x squareds together, I'm at 2x squareds equals something squared. And now how do I get rid of this square? I'm going to square root both sides. So the question mark ends up being, now you need to simplify that. And if you simplify square root of 2x squared, I would, multiplication is happening between these two, I would split it up into square root of 2 times the square root of x squared. And the square root of 2, that's as simplified as it'll get. There's nothing perfect in it, so it can't come out. And this one just becomes x, because the square and the square root cancel out. So this simplifies to x, that comes out of the root, because it was perfect, and then root 2 stays in. So our hypotenuse on a 45, 45, 90 triangle is x root 2 every single time. So 45, 45, 90, something to reference, because you won't want to make use of the Pythagorean theorem every time. The legs are equivalent to x's, and the hypotenuse is x root 2. Okay? All right, the other type of right triangle, special type of right triangle, does not come from a square. It originates as a equilateral triangle. So let's say, because of easiness here, we'll say each side length is not x, but 2x. Because it's equilateral, all sides are going to be the same. Then I'm going to come through this, and I need to make a right triangle. So how I'm going to do it is I'm going to cut this down the middle. So now I have a right triangle that's formed, and I'm going to take out this other part. So I have this happening. This is the hypotenuse of my right triangle, and it's equivalent to 2x. This, the leg, well, it's not 2x anymore. It got chopped in half, so it just becomes x. And now the other leg. Well, the other leg is not x because it wasn't one of the sides that got chopped in half of the equilateral triangle. It's straight down the middle. So in order to find it, we're going to make use of the Pythagorean theorem. Also, you can see it's not going to be the same as x because this one is 60 degrees. What happened to this 60? It got chopped in half. So it's not 60 anymore. This is actually 30. So this special type of right triangle, the other one, is a 30, 60, 90 triangle. And its side lengths will always be in this pattern of 2x for the hypotenuse. One of the legs that's attached adjacent to the 60-degree angle will be half of the hypotenuse. And then the other leg, we're going to solve for that right now by using the Pythagorean theorem. So I have x squared for a leg plus the other leg, I don't know, equals 2x the quantity squared. Simplify everything. This will become 4x squared. This is x squared plus question mark squared. To get question mark alone, I'm going to get this to the other side by subtracting x squared. So I end up at question mark squared equals not 4 anymore, but 3x squareds. And now I need to get rid of the square. So I'm going to square root. And now I need to simplify the square root of 3x squared. So I'm going to split that up. Square root of 3 times square root of x squared. This is not perfect, and there's nothing perfect in it. Sorry, 3. So it's going to stay. And then the x squared is, so I'm going to cancel that out, and I'm just left with x there. So I'm going to have x on the outside and root 3. So if I go back, my 30, 60, 90 special right triangle is going to have a hypotenuse of 2x, a leg adjacent to 60 at x, and then the other leg adjacent to 30 turns out to be x root 3. Okay.